it sure looks a lot like it's motion, and if it repeats indefinitely, it sure looks a lot like perpetual motion.
The universe is whispering a secret, one that could unravel everything we thought we knew about energy, time, and the very fabric of reality. Imagine a world where energy flows endlessly, like a river that never dries, powering our homes, our dreams, our future, without ever running out. This isn't a fairy tale or a sci-fi dream spun from the minds of hopeful storytellers. This is real, and it's happening now. At MIT, scientists have just ignited a spark that might light the way to this future. They've created a quantum time crystal, a strange and mesmerizing form of matter that seems to dance to its own eternal rhythm, defying the rules of physics as we know them. It's a breakthrough that feels like it's been plucked from the edge of possibility, a whisper of something so profound it could change the course of humanity. But what does it mean? Could this shimmering, oscillating marvel really be the key to infinite energy? Or is it something even stranger, something that might bend the very nature of time itself? Buckle up, because we're about to dive into a story that's as thrilling as it is mind-bending, a tale of mystery, discovery, and a future that's suddenly within reach. Picture a cold, sterile lab at MIT, where the air hums with the quiet buzz of quantum computers and the weight of anticipation. Scientists huddle around screens, their faces lit by the glow of data that could rewrite the laws of the universe. They're not chasing a fleeting theory or a distant dream. They're chasing something tangible, something alive in its own peculiar way. What they've created is a quantum time crystal, a structure so bizarre it seems to mock the rules that govern our world. Unlike anything you've ever seen, this crystal doesn't just sit there. It moves, it oscillates, it pulses with a rhythm that never stops. Not because someone's pushing it, not because it's drawing energy from some hidden battery, but because it exists in a state of perpetual motion. No friction, no energy loss, just an endless dance that defies everything we've been taught about how things work. To understand why this matters, let's step back and think about the world we know. When you roll a ball across the floor, it eventually stops. Friction, gravity, the messy reality of our physical world, it all conspires to slow things down. Energy is always lost, seeping away into the environment like water through a sieve. But this quantum time crystal, it laughs in the face of those rules. It keeps moving, keeps vibrating, keeps going without ever needing a push. It's as if it's found a loophole in the laws of physics, a secret passage through the universe's rulebook. This isn't just a lab trick or a quirky anomaly. This is a glimpse into a realm where the impossible becomes possible. Back in 2012, a Nobel laureate named Frank Wilczek dared to imagine this. He proposed that a phase of matter could exist, one that breaks the symmetry of time itself, oscillating forever without losing energy. It was a wild idea, dismissed by some as a physicist's fantasy, a theoretical curiosity too strange to be real. But Wilczek's vision wasn't just a thought experiment, it was a challenge to the scientific world, a call to push the boundaries of what we believe is possible. For years, researchers across the globe chased this dream, piecing together clues in the quantum realm, a place where particles can be in multiple states at once, where the rules of reality twist and bend. And now MIT has done it. Using the delicate, almost magical power of quantum computers, they've brought Wilczek's vision to life. They've created a system of qubits, those strange quantum bits that power the next generation of computing, and coax them into forming a time crystal. It's not just a scientific victory, it's a moment that feels like the universe is winking at us, inviting us to peer deeper into its mysteries. But why does this matter to you, to me, to the world outside the lab? Let's dream big for a moment. Energy is the lifeblood of our civilization. It powers our cities, our phones, our ambitions. Yet every source we rely on, oil, coal, even solar and wind, comes with limits. Fossil fuels choke the planet and dwindle with every passing year. Renewables depend on the sun's whims or the wind's caprice. Batteries, no matter how advanced, leak energy over time. Now imagine a source that never runs dry, a system that generates power without burning fuel, without waste, without end. The quantum time crystal hints at this possibility. Its endless oscillation suggests it could tap into something called zero-point energy, the faint hum of energy that exists even in the emptiest corners of space. If we could harness that, we'd be looking at a revolution, not just in energy, but in everything. A world where clean, limitless power is as common as air. A world where scarcity is a relic of the past. The implications are staggering, almost too big to wrap your mind around. But before we get carried away, there's a catch, because there's always a catch. Creating a quantum time crystal isn't like flipping a switch. It's more like threading a needle in a hurricane. These crystals only exist under the most precise, delicate conditions, temperatures near absolute zero, environments so controlled they make a clean room look chaotic. The slightest disturbance, the tiniest flicker of heat or vibration, can shatter the fragile dance of the time crystal. MIT's team, led by visionaries like Professor Mael Lukin, used a quantum computer to create this marvel, manipulating qubits with a precision that borders on the miraculous. But scaling this up, taking it from a lab experiment to something that could power a city, that's a puzzle we're nowhere near solving. The conditions needed are so extreme, so finicky, that practical applications feel like a distant star, visible, but not yet within reach. And yet the fact that we've even seen this star, that we've touched it in a lab, is a testament to human ingenuity. It's a reminder that what seems impossible today might be tomorrow's reality. This discovery isn't just about energy, though. It's about rewriting our understanding of the universe. Time crystals challenge the laws of thermodynamics, the bedrock rules that tell us energy must always dissipate, that systems must eventually settle into stillness. By existing in a state of perpetual motion, these crystals are like a cosmic rebellion, a hint that there's more to reality than we've ever imagined. They're not just a new kind of matter, they're a new way of thinking about time itself. In our everyday lives, time is a straight line, ticking forward relentlessly. But in the quantum realm, time can loop, twist, oscillate. What does it mean to create something that seems to live outside the normal flow of time? Could this be the first step toward not just harnessing energy, but bending the very fabric of reality? The questions are as thrilling as they are unsettling, pulling us into a story that's only just beginning. The story of the quantum time crystal doesn't just stop at a flickering hope of endless energy. It stretches further, tugging at the edges of our imagination, where the boundaries of time, space, and possibility blur into something almost mystical. Standing in the glow of MIT's breakthrough, we're not just witnessing a scientific milestone, we're teetering on the edge of a new frontier, one that feels like it's been ripped from the pages of a cosmic novel. This strange, shimmering crystal, pulsing endlessly in a quantum dance, isn't just a curiosity in a lab. It's a key, a riddle, a whisper from the universe that says there's more to reality than we've ever dared to dream. But as we lean into this mystery, the air grows thick with questions. Can we really harness this bizarre phenomenon? What does it mean for our future? Not just for energy, but for the way we understand the world? And what if this crystal, this tiny rebellion against the laws of physics, is pointing us towards something even stranger than infinite power? Let's step deeper into this tale, where the stakes are as high as the stars, and the answers are as elusive as time itself. Imagine the quantum realm, a place so alien it makes our everyday world feel like a shadow of something greater. Here, particles don't just sit still. They flicker between states, existing in a haze of possibility. It's in this realm that the time crystal thrives, a creation that seems to defy the very laws that hold our universe together. To grasp its power, let's think about energy again. But this time, let's go bigger. Every energy source we've ever known, from the coal that fueled the Industrial Revolution to the solar panels gleaming on modern rooftops, relies on a trade-off. You burn something, you harness something, you lose something. Even the most efficient systems bleed energy, like a bucket with a tiny hole. But the quantum time crystal, it's different. It oscillates, it moves, it hums with a rhythm that never fades, and it does so without ever losing a drop of energy to the world around it. This isn't just a neat trick. It's a middle finger to the laws of thermodynamics, those sacred rules that say everything must eventually grind to a halt. The crystal's endless motion suggests a possibility so wild it feels like a fever dream. What if we could tap into a source of energy that doesn't just last forever, but exists in harmony with the universe's deepest secrets? This idea brings us to zero-point energy, a concept that sounds like it was born in the mind of a science fiction writer, but is very real to physicists. Zero-point energy is the hum of the universe itself, the faint buzz of energy that lingers even in the emptiest reaches of space, where no matter, no light, no heat exists. It's the energy of nothing, the ghost of possibility that quantum mechanics insists is always there. For decades, scientists have speculated about tapping into this invisible sea of power, but it's remained just out of reach, a tantalizing mirage. Could the quantum time crystal be the bridge to that dream? Its ability to oscillate without losing energy hints that it might interact with this zero-point field in ways we don't yet understand. If we could learn to manipulate these crystals, to amplify their strange, eternal rhythm, we might unlock a source of power that doesn't just change how we light our homes, it could transform the very structure of society. Picture a world where energy isn't a commodity fought over by nations, but a gift as abundant as the stars. No more wars over oil, no more skies choked with smog, no more communities left in the dark. It's a vision so breathtaking it feels almost too good to be true. But here's where the story twists, where the glow of possibility meets the shadow of reality. Creating a quantum time crystal is like catching a snowflake in a storm. It's delicate, fleeting, and maddeningly difficult. These crystals don't just form on their own. They require conditions so precise they border on the absurd. We're talking temperatures colder than the void of space, environments shielded from even the faintest whisper of interference. MIT's team pulled this off using a quantum computer, a machine that's itself a marvel of human ingenuity, capable of manipulating particles at the quantum level with a precision that feels almost supernatural. They use qubits, those strange building blocks of quantum computing, to create a system where the time crystal could come to life, oscillating in a state of perfect, unending motion. But this is a lab experiment, a fragile miracle confined to a tightly controlled world. Scaling it up to something that could power a city or even a single light bulb is a challenge that makes climbing Everest look like a Sunday stroll. The crystals are so sensitive that a stray photon, a flicker of heat, could disrupt their dance. And even if we could stabilize them, we don't yet know how to extract energy from their motion in a practical way. The dream of infinite energy is there, shimmering on the horizon, but the path to it is littered with obstacles we're only beginning to understand. Yet even as we grapple with these challenges, the time crystal's potential stretches beyond energy. It's not just about powering our world, it's about redefining it. Quantum computing, already poised to revolutionize everything from medicine to cryptography, could get a massive boost from time crystals. These strange structures could help stabilize qubits, which are notoriously fragile, prone to losing their quantum state at the slightest disturbance. If time crystals can maintain their oscillation indefinitely, they might offer a way to keep qubits in their delicate dance for longer, making quantum computers faster, more reliable, and capable of solving problems we can't even imagine yet. Imagine a computer that doesn't just crunch numbers, but unlocks the secrets of the universe, simulating new materials, cracking codes thought unbreakable, or even modeling the behavior of black holes. The time crystal could be the key to this future, a tiny spark that ignites a revolution in how we process information. And it doesn't stop there. Some physicists, their voices tinged with both excitement and caution, whisper about even wilder possibilities. Could time crystals, with their strange relationship to time itself, offer clues to manipulating the very fabric of reality? Could they help us understand not just energy, but the nature of time at the quantum level? These questions pull us into a realm where science starts to feel like philosophy, where the line between discovery and dream blurs into something awe-inspiring. But not everyone is ready to buy into the hype. There's a chorus of skeptics, their voices sharp and grounded, reminding us that the road from lab to reality is long and treacherous. Some argue that time crystals, while fascinating, might remain a scientific curiosity, a beautiful anomaly with no practical use for generations. The leap from a quantum computer's sterile environment to a power grid is enormous, they say, and the idea of harnessing zero-point energy is still more fantasy than fact. Even the most optimistic researchers admit that we're decades, maybe centuries, away from turning time crystals into a viable energy source. And yet, even these skeptics can't deny the crystal's allure. It's a puzzle that challenges everything we know, a reminder that the universe is far stranger, far richer than we've ever imagined. Every great discovery starts with a spark of the impossible: electricity, flight, the internet. And the quantum time crystal feels like one of those sparks. It's not just a new kind of matter, it's a new way of seeing the world, a glimpse into a future where the rules we've lived by might no longer apply. As we stand at this crossroads, the quantum time crystal feels like a message from the universe, a challenge to keep pushing, to keep dreaming. It's a reminder that the impossible is only impossible until someone proves it otherwise. The scientists at MIT didn't just create a crystal, they opened a door, one that leads to a future we can't yet fully see. Will it lead to infinite energy? To quantum computers that reshape our world? Or to something even stranger, something we can't yet name? The answers lie ahead, hidden in the quantum haze, waiting for us to find them. And as we chase those answers, we're not just chasing science. We're chasing the very essence of what it means to be human, the drive to explore, to understand, to reach for the stars. The quantum time crystal gleams like a beacon in the fog of the unknown, its endless oscillations whispering of a future we can barely comprehend. We've journeyed through the thrill of MIT's discovery, marveled at its defiance of physics, and dreamed of a world where energy flows without end. But now, as we stand at the edge of this cosmic cliff, the story takes a turn into the profound, the philosophical, the almost unimaginable. This isn't just about powering our cities or revolutionizing our computers. It's about touching the very essence of reality itself. What if the quantum time crystal isn't just a key to infinite energy, but a window into the nature of time? What if it's a clue to bending the fabric of the universe, to rewriting the rules that govern our existence? As we dive into the final chapter of this tale, the air grows heavy with possibility, with questions that tug at the heart and mind. This is no longer just a scientific breakthrough. It's a call to rethink everything we know, a challenge to imagine a world where time itself might dance to our tune. Let's pause for a moment and let the weight of this sink in. The quantum time crystal, this strange pulsating marvel, doesn't just challenge the laws of thermodynamics. It challenges our understanding of time. In our everyday lives, time is a river, flowing in one direction, relentless and unyielding. We measure it in seconds, hours, years, marking our lives by its steady march. But in the quantum realm, where the time crystal thrives, time isn't so simple. It loops, it oscillates, it defies the linear path we take for granted. The crystal's eternal rhythm suggests that time, at its deepest level, might not be a straight line, but a symphony of cycles, a dance of infinite patterns. Some physicists, their voices hushed with a mix of awe and daring, speculate that time crystals could be the first step toward manipulating time itself. Not time travel in the Hollywood sense, no DeLoreans or wormholes here, but something subtler, something that could let us peek into the mechanics of temporal flow. What would it mean to control time at the quantum level? Could we slow it, stretch it, harness its rhythm to unlock secrets we've never dreamed of? The very idea feels like standing at the edge of a void, staring into a mystery that's both thrilling and terrifying. This possibility, as wild as it sounds, isn't just a flight of fancy. The time crystal's ability to exist in a state of perpetual motion without energy loss suggests it's tapping into something fundamental about the universe, something that ties together energy, matter, and time in ways we're only beginning to grasp. MIT's breakthrough, achieved in the pristine confines of a quantum computer, is a proof of concept, a spark that could ignite entirely new fields of science. Imagine a future where we don't just harness energy from these crystals, but use their strange properties to explore the fabric of space-time itself. Could they help us understand black holes, where time and gravity twist into knots? Could they unlock new ways to model the universe, to predict its past or shape its future? These questions pull us into a realm where science brushes against philosophy, where the line between discovery and destiny blurs. The time crystal isn't just a scientific curiosity, it's a challenge to our place in the cosmos, a reminder that we're part of something vast, something that's still revealing its secrets. But let's bring this back to Earth for a moment, to the human stakes of this discovery. If the quantum time crystal leads to a breakthrough in energy, say a way to tap into zero-point energy, the implications for our world are nothing short of revolutionary. Energy is more than just power. It's the heartbeat of progress. It's what lights our homes, fuels our industries, and drives our dreams. Yet today, in 2025, we're still grappling with the consequences of our reliance on finite resources. Climate change looms like a shadow, with wildfires raging, oceans rising, and communities struggling to adapt. Energy scarcity fuels conflicts, divides nations, and leaves millions in the dark. Now imagine a world where energy is no longer a battleground, but a shared gift. A world where clean, limitless power flows to every corner of the globe, lifting communities out of poverty, powering schools and hospitals, and giving us the tools to heal our planet. The quantum time crystal, with its promise of endless energy, could be the key to this future. A future where humanity doesn't just survive but thrives, unshackled from the limits of scarcity. Yet even as we dream of this utopia, we must face the shadows. The path to harnessing time crystals is fraught with challenges, not just scientific but ethical and societal. If infinite energy becomes reality, who controls it? Will it be a gift shared equally, or a prize hoarded by the powerful? History tells us that great discoveries, fire, electricity, nuclear power, come with responsibilities as great as their potential. The same technology that could light the world could also deepen inequalities if we're not careful. And then there's the question of time itself. If we learn to manipulate it, even in the smallest way, what does that mean for our humanity? Time shapes our stories, our memories, our sense of who we are. To tamper with it, even at the quantum level, is to touch something sacred, something that defines our existence. These are not just scientific questions. They're moral ones, philosophical ones, questions that demand we think not just about what we can do, but what we should do. The skeptics, ever present, remind us to temper our excitement. They point out that time crystals, for all their wonder, are still a long way from changing the world. The conditions needed to create them, near absolute zero temperatures, perfectly controlled quantum environments, are so extreme that practical applications feel like a distant dream. Some argue that the energy potential of time crystals might never materialize, that they'll remain a fascinating quirk of quantum physics, studied in labs but never powering our lives. Others caution that zero-point energy, while theoretically possible, is a concept we're nowhere near mastering. The leap from a lab experiment to a global energy solution is monumental, they say, and we may need decades, even centuries, to bridge that gap. Yet even these skeptics can't help but feel the pull of the time crystal's mystery. It's a reminder that science isn't just about answers. It's about questions, about pushing into the unknown, about daring to dream of what lies beyond. As we stand at this crossroads, the quantum time crystal feels like a gift and a challenge. It's a gift because it shows us that the universe is still full of surprises, that we're capable of uncovering truths that reshape our world. It's a challenge because it asks us to rise to the occasion, to solve the puzzles it presents, to navigate the ethical minefields, to dream responsibly. MIT's discovery isn't the end of the story, it's the beginning. It's a spark that could light a fire, a whisper that could become a roar. Whether it leads to infinite energy, to breakthroughs in quantum computing, or to a deeper understanding of time itself, one thing is clear: we're on the cusp of something extraordinary. The quantum time crystal is a reminder that the universe is not a closed book but an open one, its pages waiting for us to write the next chapter. So let's keep asking, keep exploring, keep dreaming. Because if this tiny oscillating marvel has taught us anything, it's that the impossible is only impossible until we make it real.